My research is all about how to give things away. And today in this video, I want to tell you a little bit about the random priority mechanism and why it's so cool. So let's talk about the setting first of all. So we have some objects to give away to people. Here on the right, I'm representing those objects as different fruits, right? And so we want to find a good allocation, a way to assign fruit to people. The challenge is that we don't actually know people's preferences. We don't know which fruit they like. And so the approach we want to take is we're going to start by asking people to rank the objects. Tell me your first choice fruit, your second choice fruit, and so on. And then from the information we collect from everyone, we somehow need to apply some algorithm to this to find a good allocation. Well, we can represent people's preferences in the following way, right? So for each person, we have a visual representation where maybe their favorite fruit is on top and their least favorite on the bottom. So here, agent 2 likes the apple best, followed by the banana, followed by the cantaloupe, and the durian is their least favorite object, while agent 3 actually thinks the banana is best. From this information, we're going to calculate an allocation. So for example, here's one possible allocation. We could give the apple to agent 1, the banana to agent 2, the cantaloupe to agent 3, and the durian to agent 4. Okay, so what do I mean by we want to do this in a good way? Well, specifically, I'm thinking we want to satisfy 3 important properties. So first of all, the allocation should be efficient. Informally, this means that no set of agents should want to trade items with each other. Second, we want the allocation to be fair, which in this video, we're going to interpret as meaning we should treat people equally, right? We don't want to prioritize one agent's needs over another. And so that's going to involve some sort of randomization in order to make this fair. And finally, we want the allocation to be, or the mechanism to be truthful, right? So in particular, we're asking people to rank items for us, and it should never be the case that they can get a better item by lying about what they want. And so all 3 of these can be made mathematically precise definitions. I'm not going to go into those definitions in this video, but at a high level, these are the goals we want: efficiency, fairness, and truthfulness. Okay, let's think about some allocations we could do. One thing we could do is we could just give the fruit away randomly, right? So this is going to be fair. We're treating everyone equally. It's also going to be truthful. Since I'm ignoring whatever you tell me, there's no incentive for you to lie. But it's clearly not going to be efficient, right? If one person prefers bananas to apples and one person prefers apples to bananas, I might actually allocate each of them the wrong fruit in a way that they would want to trade after the fact. Another thing I could do is I could ask for your preferences and then run some sort of optimization algorithm. So for example, I could minimize the sum of the ranks, try to give as many people high-ranking objects as possible. And to make this fair, I could do some sort of random tie breaking if there are ever multiple allocations that maximize my objective function. So then this would make the allocation both efficient and fair, but it turns out this is not going to be truthful. There are going to be cases where you might actually benefit from telling me that you don't like a particular fruit, even when you do. Okay, a third approach we could take is maybe a draft. This is probably pretty familiar with you, right? So I'm going to line agents up, and I'm going to, starting with the first agent, ask them to choose their favorite fruit, and then have the second agent choose their favorite fruit from the remaining items, and so on down the line. Okay, it turns out this is going to be both efficient and truthful. No one's ever going to be able to benefit from lying, but it's not very fair, right? Because the first agent gets whatever they want. However, we could make this fair by putting people in a random order, right? And so we'll call this random priority. It's also sometimes called random serial dictatorship. So again, this is just put people in a random order and then have them choose one by one, starting from the top. And it turns out this is efficient, fair, and truthful. So this seems pretty great. Of course, there are other things you could do that would also be efficient, fair, and truthful. So one possibility is actually, you could start by just giving away items randomly like we did before, but as we noted, that wasn't efficient. And so you can fix that by basically having a series of trades starting from a random allocation to reach an efficient allocation. And it turns out you can run this series of trades in an organized way that makes the final allocation efficient, fair, and truthful. So this seems like a pretty good mechanism, right? Give things away, have a bunch of trades, do it in a way that no one wants to lie to you. So this is very appealing. So I have a couple of amazing facts for you. Amazing fact number one is that these two approaches I just described actually turn out to be equivalent, right? So lining people up in a random order and having them choose, and allocating random items and then having them trade, those turn out to be equivalent, meaning that for every agent, their chance of getting each object is identical across the two mechanisms. So if random priority gives you a 30% chance of getting your favorite object and a 20% chance of getting your second favorite, then random allocation with trading also will give you a 30% chance of your first object and a 20% chance of your second object. Pretty cool and pretty amazing. Definitely requires a proof. A second amazing fact is that actually nobody knows any other way to allocate objects that is efficient, fair, and truthful. In other words, every known way to do this is actually equivalent to random priority. Now, this might inspire the question, can we actually prove that random priority is the only way to allocate efficiently, fairly, and truthfully? And we don't know the answer to that question. No one's been able to prove this yet, and yet no one's been able to come up with a counterexample. So that's just like, I would say, one of the most fundamental and interesting open questions in my field. So in conclusion, I think a lot of people have encountered random priority, right? The idea of lining people up and having them choose and maybe making the order in which they choose random all seems extremely natural, but maybe overly simplistic. And our first instinct is, well, surely, expert researchers have better ways of doing things. The reality is actually random priority is a very reasonable approach, right? Depending on what you want, this may very well be the best way to allocate items. And so when you go out in the real world, if you want to allocate in a way that treats people equally, is efficient, and is truthful, you can use random priority with confidence and know that nobody actually knows of another way to do things that satisfies these three axioms. Pretty cool stuff, right? Thanks for listening, and be sure to check out my webpage, nickarnasti.com, for blog posts and research articles all about giving things away.